All right, now let's talk about how to take the derivative of arcsine. Arcsine or inverse sine, right? They're the same thing. Arc sine of x. So you know that if I see sine to the negative 1 of x, that does not mean 1 over sine of x, correct? Does not. Okay, so it means arcsine. All right, so I'm going to do a little math enrichment here. So if I take the sine of both sides, I get sine of y equals x. So if I'm going to do implicit differentiation, so I get derivative of sine is cosine of y, carry the angle along, and then multiply by y prime, the derivative. Derivative of x is just 1. Solving for y prime, I get 1 over cosine. So I need to get back to x's. So let's see, what do I know about cosines and sines? I know cosine squared of any angle plus sine squared of the same angle gives me 1. So solving this for cosine, so subtract over sine squared, take the square root, then that's 1 minus sine squared of y. Well, I know that sine of y is equal to x. So cosine of y is equal to 1 square root of 1 minus x squared. So there's y prime. 1 over the square root of 1 minus x squared. Wow. Nothing like you'd expect. And I can go through the same kind of identity to talk about inverse tangent. It's going to be 1 over 1 plus x squared. And of course, you know if it's not just an x here, and it's g of x, you get to do chain rule, carrying the g of x along and then multiplying by the derivative of the g afterwards. So let's go play. So the derivative of arcsine will be 1 over the square root of 1 minus the angle squared times the derivative of the angle I carried along, which would be 3x squared, plus derivative of arctangent, it would be 1 plus the angle squared times the derivative of the angle, which would be 4x cubed. So let's just make sure we're good with simplifying. So you know to multiply those exponents. And then 1 over 1 plus x to the 8th. And then on the top, you would have a 4x cubed. All right, so let's take the derivative of this. So derivative of arcsine of e to the x be 1 over the square root of 1 minus e to the x squared times the derivative of e to the x, which is e to the x, minus 1 over 1 plus the angle squared times the derivative of the angle, which would be cosine of x. So let's just make sure we're good about how to multiply these. So you multiply those exponents, so you would get e to the 2x minus, and then 1 plus sine squared of x, and then, a cosine on the top, right? Cosine of x, and that's as simplified as it gets. All right, so these can come up in implicit. Well, this one's implicitly, but this one's just more fun. Okay, so let's go find the derivative. So I'd get 1 over the square root of 1 minus the angle squared times the derivative of the angle, plus arctangent, 1 over 1 plus the angle squared times the derivative of the angle. Next term, so this one has a square root on the outside. So we've got more layers, so all this is to the negative 1/2 power. Now take the square root of the arcsine, 1 minus 4x squared times the derivative of the 4x, which is 4. Okay, and so this last term here, so minus, so I'm going to take 1 over 1 plus, and I'm going to be taking putting in the radical x and squaring it, which does turn out to be x, but I still need to multiply by the derivative of root x, which is 1/2 x to the negative 1/2. All right, so let's just clean this up so you can see what I've got. So I've got 3e to the 3x over 1 minus, again, you multiply those exponents, so you get 6x, plus 4e to the 4x, 1 plus e to the 8x, plus 1/2 inverse sine of 4x to the negative 1/2, and this is all times of 4, so I guess we can Let's get rid of that and make it a 2 on the outside. Square root of 1 minus 16x squared. And then here, minus, I'll just leave this guy up here, and then I'd have 1 plus x. All right, so let me just make a comment about this derivative of arctangent of root x. So if I was to just 1 plus and then think, oh yeah, the root x squared is x, I might think I'm done, because then you might think, incorrectly, you might think, oh, the derivative of x, that just gives you 1, right? So that's wrong. So what I want you to remember always, you can always simplify this because root x squared is x, is always what you're going to be multiplying by is the derivative of that angle, the original angle. So that's how it turned into 1/2 x to the negative 1/2. So be careful.